In this lesson, we're going to learn how to solve quadratic inequalities algebraically. So on your note guide, we begin by asking, how do we solve this quadratic equation? We learned several methods. My personal favorite was to factor and apply the zero product property. So you can always do tic-tac-toe off on the side if you still have not been able to speed up your factoring process, but this would be factors of -15 that add to -2. So I'm going with -5 and +3. So x minus 5 times x plus 3 is equal to 0. So when I apply the zero product property, I get x minus 5 equals 0, which gives me x equals 5, or x plus 3 equals 0, and x equals -3. These are known as the zeros of my function if I were to graph a function. So let's now consider, how does this change if I switch my equal sign to a greater than sign? So I'm really saying, so when is this positive? When is what positive? Well, if I think about a corresponding function, if I called this a parabola, f of x, I'm saying, where is my parabola positive? Well, we just figured out that the zeros are -3 and +5, and this particular parabola would open upward and have a vertex down below the x-axis somewhere. And I'm saying, so where is it positive? Well, it would be positive in this portion and this portion of the parabola. So what values are still important here? Well, certainly the zeros. So when we solve quadratic inequalities, we're going to need to find our zeros. And what we're going to do is we're going to go to a number line, and you're going to begin by placing your zeros on that number line, which are -3 and +5. Now, I'm just going to leave these as an open circle as I think about this, because my question is, where is it greater than 0? Not equal to 0. And zeros is clearly where it's equal to 0. It's what they're called, for goodness sakes. Okay. The easiest thing to do now is to choose a test point. And I like to choose a value between my two zeros if I have to. So I'm going to pick 0. Why 0? Because I'm going to be plugging it into my function, and 0 is a super easy number to plug into my function. It would give me, 0 squared minus 2 times 0 minus 15 would be a -15. Now, all I really care about is that it's negative. So that means it's negative completely in between those two zeros in this region. Well, and I can see that here, yeah, it's down below the x-axis. Here it's above, here it's above. So based on what I know from parabolas, it means it's positive over here and here. So my solutions are this part. So how do I write this solution now? There are two ways. If you're asked to write it as an inequality, well, this would be a compound inequality. I would say that x is less than -3 or x is greater than 5. We also learned interval notation. If you're asked to express your answer in interval notation, our solutions go from -infinity to -3, and -3 is not included, union 5 to +infinity, also with a parentheses. So both are acceptable ways of writing your solution. You just need to read directions and see what's asked. When you do your practice in GMM, it usually asks you to write it as an inequality, and I believe the multiple choice questions are in interval notation. But that, of course, could change at any time, so just read. Let's go over to this one. We are to solve this quadratic inequality. So I'm going to begin by putting this in standard form, which means I will subtract x and 2 to bring everything to the left. So 10x squared minus x minus 2 is less than or equal to 0. Now I'm going to try to factor this to see the zeros of my function, and I would encourage you to do tic-tac-toe if you need to. I'm going to try 5x and 2x would give me 10x. Factors of negative 2 would be 2 and 1. I'm going to put the 2 here, the 1 here. Multiply across is negative 5x, and 4x does add to negative 1x. So my one factor is 5x plus 2. My other is 2x minus 1. So the zeros of my function would occur when I set both of these equal to 0. So 5x plus 2 equals 0. Subtract 2, divide by 5 would be x equals negative 2/5. The other one would be 2x minus 1 is equal to 0. 2x equals 1, divide by 2, x equals 1/2. So here are the zeros. Now I'm going to make a number line. I'm going to put these zeros on my number line, negative 2/5 and positive 1/2. And I'm considering where is this quadratic equation less than or equal to 0. So I'm interested in where is it negative or equal. So I already know it's equal at this part, so I'll make those closed circles. Now let's decide where is it negative. Again, I'm going to choose a test point. I'm going to pick 0. It's in between here. If I plug in 0 into my function, I'd have 0 minus 2 is a negative. So it's negative here, which means it's got to be positive out and out if I have, a parabola that's cutting through the x-axis. So how do I write my solution? Let's write it as an inequality. I'll shade. Oops, I just didn't mean to do that. We are shading where it is negative, so that's the region in between. So as an inequality, my solution would be negative 2/5 is less than or equal to x, which is less than or equal to 1/2. If you were asked to express this in interval notation, it would be negative 2/5, comma 1/2, and both would get brackets. Okay, we've got 2 more to go here. One more, just like the last. We are solving this inequality. And we're being asked, where is this greater than 6? So again, I start by putting it in standard form. So I'm going to subtract, and that would give me 2w squared minus 9w plus 4 is greater than 0. So I'm checking where is this positive this time. So again, I'm going to attempt factoring. If factoring doesn't work, I would have to try the quadratic formula to get my zeros. But for most of these, I have them set up that they will work out to nice rational numbers. So do your factoring off on the side. And I get 2w minus 1 times w minus 4. So to find my zeros, that would be 2w minus 1 equals 0. Gives me 2w equals 1, or w equals 1/2. The other one, w minus 4 equals 0, would be w equals 4. So here are the zeros. But what am I interested in? Where is my function, or where is my quadratic, greater than 0? So where is it positive, in other words? So when I put my zeros on here, I'm not interested in where it equals 0. So this is where it equals 0. I'm interested in where is it positive. So again, I'm going to choose a test point. So I like to choose 0. So 0 is over here this time. So if I pick 0 and plug it in to my function, if I plug it in right here, that would give me 4. So that tells me it's positive over here. So it would be negative in the middle and positive out on this side. So where is it positive? Well, I'm going to shade out here and out here. So how do I write my solution? Well, as an inequality, it would be a compound inequality. W is less than 1/2, or w is greater than 4. In interval notation, this would be negative infinity to 1/2, union 4 to infinity. Remember to always read instructions to know what form you're asked to express your answer. So inequality versus interval notation. Okay, so I think we got one last one to go here. This time, given this graph, write the quadratic inequality. So this is a great question. Well, what do we know here? If this were a parabola that dipped below like this, it would be positive there and there. And that would match my graph if this value were -2 as a 0 and this value is 5. So I'm going to say, where is this positive, whatever my quadratic is, where is it greater than or equal to 0? And I'm going to list my two zeros. Well, my zeros are -2, so the corresponding factor would be x plus 2. Over here, corresponding, the 0 is 5, so the factor would be x minus 5. So really, this is an inequality. I could certainly multiply it together, x squared minus 5x plus 2x minus 10. Let's see, where is that greater than or equal to 0? So just to put it in simplest form, x squared minus 3x minus 10 is greater than or equal to 0. So that should give you several examples now to go on and complete your assignment.